Hello everyone, I just want to share with you the answers from the analytic geometry assessment that we just did. This way you can check your work at your convenience. Okay, beginning on the first page, our first question was to identify the slope and y-intercept for this equation. If you recall, our slope-intercept equation is y equals mx plus b. So the m would be found in front of the x, so 6, m equals 6, and then the b will be found at the end, so negative 2. Remember that that 2 owns the minus. The second question says to identify the x and y-intercepts for this particular equation. If you recall, I had mentioned that we could define the y-intercept. We set x equal to 0, and what happens is this term here, the 5x, 5 times 0, it becomes 0. I end up with just minus 2y equals 10. Divide both those sides by the minus 2, and I get y equals negative 5. Similarly, I can find the x-intercept the same way by setting y equal to 0. For number 3, I wanted to do the rise over the run. It's very important that if you're comparing the same point at the same time. So for instance, the 1 for your rise is your y values. So 1 minus the 0. So 1 minus 0 is 1. The run would be your x values. So I'm going to have to start with the second point again because I started with the second point the first time. So I'm going to look at the 4 this time because it aligns with the 1 that's above it. Do you see that? So then I get 4 minus 6, and that's going to give me my run of negative 2. So then my slope is negative 1 over 2. Number 4, the line is y equals 2/3 x. A perpendicular line, you have to take the slope of this line, the original line, 2/3. You're going to flip it and make it a negative. That's called a negative reciprocal. In number 5, parallel lines have the same slope. So looking at our slope in front of x is 3. So a parallel line would have a slope of 3. Moving on, we had to graph the line, we had to look at this line and come up with the slope and the equation. So the slope of the line is just rise over run. I need to see that triangle on your graphs, please. So my rise is 2. I just chose 2 really nice points. This one's good and this one's good. So in order to get from this point to the second point, I'm going to rise 2 and run 5. So my slope then would be 2 over 5. Now where did I start? I started at minus 3, so that would be my y-intercept. At the bottom, parallel lines have same slope and perpendicular lines have negative reciprocal slopes. Okay, so this is a lot of multiple choice. Which of the following equations is equivalent to this? So you had to rearrange it. In order to rearrange it, you're going to get the y by itself. So looking at this equation, I have minus 5y, bring the 3x to the other side, equals minus 3x plus 45, which was already there. Then I need to divide everything through by the minus 5. So then I get y equals 3 over 5x, and the 45 becomes negative because it's 45 divided by 5, so 9. And so the correct answer is A. Which of the following equations doesn't exist? So we know that x equals 5 is a vertical line going through 5. Y equals 10 is a horizontal line going through y is 10. And we also know that here 5x minus y plus 10, because the x and the y don't have any exponents, they're not going to be anything funky. And in fact, you could just graph all 4 of these and see what happens. And you're going to find out that C is not a line. In this equation, which equation below represents a line that is perpendicular to this line? So the original line was 3. We want to, if the original line is 3, then our slope that will be perpendicular, you're going to take that 3 because it's like a 3 over 1, and you're going to flip it and change it to a negative. So you have to flip and change to a negative, and the only one that has negative 1/3 is C. This one was quite tricky. Y equals mx plus 5. So if you put in 7 for the x and 3 for the y, then you're going to find that the rise for the m is negative 2 and the run is 7. So you're just going to have to try substitute those in and see how that goes. This one we're just rearranging again to get y by itself. This one it asks which statement is not true. So if you look at this, y equals negative 3x plus 5, right away the first statement is not true. The slope is not 3, it's negative 3. Now let's just double check the other ones. The y-intercept is 5, that is true. For a rise of 3, the run is negative 1. Well, this negative could go with the top or bottom, but if it is a rise of 3, then yes, it would be a run of negative 1. And then the graph crosses the y-axis at 0, 5. That's the y-intercept again, so that's also true. The same y-intercept as this. So if I find the y-intercept for this, that's the same as if I were to so y-intercept is when x equals 0. So if this term goes to 0, the 2x goes to 0, then I get 3y minus 6 equals 0. And then if I write that, I get 3y equals 6, because the minus 6 on one side will be a plus 6 on the other. And then I need to divide both sides by the 3 to get the y by itself. So y equals 2. So the y-intercept for this equation is 2, and that's what I'm looking for. So not negative 2, not 6, not negative 6. We're actually looking for A. Again, for the last one, if you graph these, you'll see that this one comes out as a parabola, which is our grade 10 studies, and the rest of them are all straight lines. Okay, so on this page, the first one says to rewrite this in the y equals mx plus b form, so taking everything over to the other side. I'll do it below. So 6x minus 2y minus 12 equals 0. I want to keep the y here, but not the 6x and the 12. So I'm actually going to keep the minus 2y equals, I'm going to take the 6x over to the other side, becomes a minus 6x, and the minus 12 goes to the other side and becomes a plus 12. Then I'm going to divide through by negative 2 because I need to get that y by itself. So then my last line would be y equals 3x minus 6, and that gives me part B. Okay, in question 2, the line of best fit is drawn here. The slope they're telling you is negative 2. So right away, you should know if the slope is negative 2 that A and B are definitely not going to be your answer because they're not, the slope is not negative 2 for those. So my answer is C or D. In order to figure out which of C or D it is, I'm going to go up to the graph to see where it starts, and it starts at 6. So that's my y-intercept, and that's what the number is at the end in y equals mx plus b form. This one, we have y equals negative 3x plus 4, so we know we definitely need a negative slope. So A is out, and D is out because we need a negative slope. And then we're going to look at the 4. So we need to start at 4 on the y-axis. This one starts at negative 3, so no good. This one starts at 4. Oh, those lovely lines. So this question says to graph a second line on the same grid that has to go through the point negative 10 and 8, but also has a slope that is 3 times the slope of line 1. So negative 10 and 8 is go over to negative 10 and up to 8 is right here. And so that's where I'm going, one of the points that has to be on the line. The other piece of information I have is it has to have a slope that's 3 times the slope of the first line that's there. So in order to do that, I actually found the rise and the run. So I chose 2 good points on my line. I know my slope is negative because it's going down, but I choose 2 good points on here. When I did that, I got 3 is a rise and 6 is the run. So down here I said my rise was down 3 and over 6, so negative 3 over 6. That simplifies to negative 1/2. So then the new slope, because that's the slope of line 1, the new slope for line 2 that we're going to be working with is going to be 3 times as big as that. 3 times negative 1/2 is negative 3/2. I have to caution you, it is not equal to 3 over 6. Some of you are multiplying the top and the bottom by 3, and that's not correct. So this is definitely not correct. I'm going to put a big circle around it and put an X through it. So it is equal to negative 3/2, which means from our original point, negative 10, 8, we know that has to be on there. We could just follow that rule of rise over run, so down 3 over 2, beginning at our first point. And then if I keep following that rule, down 3 over 2, down 3 over 2, I can draw the entire line. Some of you, although it didn't say so, actually came up with the equation, which is also true. So y equals negative 3 halves x minus 7. Okay, on this one, we had to draw 2 lines. The first thing I did was graph the lines over here. So the first one has a negative slope, and it starts at negative 7. So I used that negative slope, so down 3 over 2, to graph my line. In order to go up, I would go up 3, but because I need it to be negative, I go back 2. Up 3, back 2, up 3, back 2, and I end up drawing my blue line. Similarly, for the second one, I'm going to start at negative 4, and according to the rise and run, I'm going to go up 2 over 3, and I can keep repeating that, up 2 over 3, until I've drawn my whole line. When you're comparing these two lines, line A moves, or goes, when you're talking about direction, it's going down as you go left to right, so it's negative. And the yellow one is going up as you move left to right. The steepness, the blue one is definitely more steep than the yellow one. Even though it's negative, it's going to be more of a ride if you were on a ski slope or something like that, so it's the faster one. These lines are definitely perpendicular. If you compare the slopes up here with negative 3 halves, if I flip that, it becomes 2/3, and it goes from a negative to a positive, so they are definitely perpendicular. To determine the slope for the first equation, or for the first relation, I need to isolate y. Bring the 5x to the other side. Divide all terms by negative 2. The equation is y equals 5 halves x minus 2. So the slope of relation 1 is 5 halves. Relation 2, I'm going to draw a rate triangle. I drew my triangle, and I realized that I went from negative 1 to 1, so my rise is 2. And I went from 0 to 3, so my run is 3. So my slope then is rise over run, or 2 over 3. I would really like to see these triangles. Every time you see a graph, you should be drawing your rate triangle or your slope triangle to figure out what the rise and the run is. So the slope for the second one is 2 over 3. Which of these relations is represented by a steeper line? 5 halves is steeper because it's a larger number than 2/3, so it's steeper. Last question. We have 2 pieces of information. We need to determine an equation of a line that is parallel to this line, parallel to this one, but it also passes through this one. And the last thing that we need to do is put it in standard form. So we're looking at the parallel first. So in order to figure out if it's parallel, then we need to find that slope. So we're going to rearrange this to get m. Keeping the minus y on the left side and moving the 3x and the 2 to the other side and changing their signs, I get this. Now I'm going to divide through by minus 1. So I get the line y equals 3x plus 2. So the slope that I want is 3. And because it's parallel, I definitely want a slope, the parallel slope would be 3. So I'm going to use this slope, and then I also have to use the point D, which is 6, 8, and come up with a new line. So I'm going to take the 6 and the 8, so that's an x and that's a y, and I'm going to put it into the formula y equals mx plus b. And because I have an x, a y, and an m, I should be able to now find b. So you can see that I've put in 8 for, there's the y, and I put it in for y. M is 3, so I put that in. X is 6, so I put that in, and now I'm going to rearrange for b. When I rearranged, I get that b equals negative 10. I'm not done because if I look back at what I'm supposed to do, I need to write this in standard form. Well, in y equals mx plus b form, I get y equals, my slope is 3, x plus b, so minus 10. But this is not standard form. Standard form, I'm going to have my x and my y on one side and my number on the other, or have it all on one side. So I'm going to bring the y over. So if I go 0 equals 3x minus y minus 10, this would be standard form. Alternately, if you had 3x minus y equals 10, that was also correct.